Hey everyone, welcome back. If you watched our previous video on Python variables and basic data types, you already know about integers, floats, strings, and booleans. Today we're taking it to the next level with advanced data types, mutability, dynamic typing, and pro-level best practices. If you haven't watched the basics video yet, the link is right up there. Go watch it first, then come back. For everyone else, let's dive in. First up, lists. A list is like a container that can hold multiple items in order. Think of it as a shopping list or a playlist. You can have as many items as you want, and they stay in the order you put them in. Let's create a list of fruits. I just created a list called fruits with 4 items. Notice the square brackets? That's how you create a list in Python. Each item is separated by a comma. When you print the list, Python shows all the items together. The best part is that you can access individual items using their index position. But here's the catch. Python starts counting from 0, not 1. That means the first item, apple, is at index 0. And here's a cool trick. Index -1 gives us the last item, orange. This makes lists really flexible because you can grab exactly the element you need. Let's see an output. Fantastic, worked as expected. In the previous example, all the items in our fruits list were strings. But here's something really cool. Lists can hold different types of data together. Let's see an example. We'll create a list called mixed list and put different types of values in it. An integer, a string, a float, and a boolean all in the same list. Now, when you print it, Python shows all the items exactly as they are in the same order. The amazing thing is, Python doesn't care about the data types. You can mix and match however you like. Next up, tuples. Tuples are very similar to lists, but with one key difference. Once you create a tuple, you cannot change it. In other words, tuples are immutable. We use parentheses instead of square brackets to define them. Tuples are perfect for storing data that shouldn't change, like coordinates, RGB color values, or any constants in your program. Accessing items in a tuple works just like lists by using the index. Let's see some examples. I will create 2 tuples. One is coordinates and another is RGB color. Here, coordinates is a tuple storing the X and Y positions, and RGB color stores red, green, and blue values. If we print them, Python shows the exact values we stored. Neat and simple. Now, just like lists, you can access items by index. For example, print coordinates 0 and print coordinate 1. So coordinates 0 gives us 10, and coordinates 1 gives us 20. But here's the catch. If we try to change a value in a tuple, Python will give an error. Tuple object does not support item assignment. This is Python protecting your data. Once a tuple is created, it's locked. This can actually be really useful when you want to prevent accidental changes in your program. So remember, tuples equals immutable, lists equals mutable. Use tuples when you want your data to stay constant, and lists when you need flexibility. Now for something unique. Sets. A set is an unordered collection that automatically removes duplicates, perfect when you only want unique values. Creating sets is very simple. Just write a variable name and then provide your data inside curly bracket separated by comma. I created a set with duplicate 3s and 4s. Watch what Python does. When we run this code, the duplicates disappeared. Sets only keep unique values. Let's look at another example of sets. I will create a sets of fruits where apple is written twice. Let's print out the fruits set. Now what if you want to count how many unique items are there in this set? Here come the len function shortcut of length. So we can write like this. When you run this code, the duplicate apple is removed automatically, and len tells us there are only 3 unique items. Now my favorite, dictionaries. These are key value pairs, like a real dictionary where you look up a word to get its definition. Creating dictionary is super simple. Let's see an example. I will create a student dictionary where we will put the detail information of a student. So let's name our variable student. And we use curly braces again, but now we map each value to its unique key using colon. Name maps to Gita, age maps to 20, and so on. Isn't it cool? Accessing values of dictionary is super intuitive. Just use the key in square brackets and you get the value. like this. Look, how beautiful is that? You can also add new key value pairs easily. Let's add the city. Now our student dictionary has a city key with the value Osaka. You can also update the existing value like this. Gita just had a birthday, changed her age from 20 to 21. Okay, this is huge. Some data types in Python can be changed after creation. Those are mutable. Others cannot be changed. Those are immutable. This concept trips up even experienced programmers. Mutable types, lists, dictionaries, and sets. You can modify them. Let's see an example from our new fruits list. This list contained two fruits, apple and banana. I will change the first fruit at index 0 to grape. Now when we print out the updated fruits, see? I changed apple to grape. No problem. Next up, immutable types, integers, floats, strings, tuples, and booleans. You cannot modify them. Let's understand this deeply. Suppose we have a variable called name where we assign a value of John. Trying to change the first letter from J to D. Error, string object does not support item assignment. But wait, you might say, what if I do this? Name equals John, name equals David, print name. Doesn't this change the string? Actually, no, we're not modifying the original string. We're creating a brand new string David and pointing the variable name to it. The original John string still exists in memory. We just abandoned it. Here's why this matters. Watch this carefully. I created list 1, then assigned list 2 equals list 1. Then I changed the first element of list 2 to 999. What do you think list 1 looks like now? Both changed. Because lists are mutable, list 2 doesn't copy the list. It just points to the same list in memory. Change one, change both. This catches beginners all the time. Let's look on another interesting subject, dynamic typing. Here's something that makes Python super flexible, dynamic typing. Your variables can change types on the fly. Let's create a variable x and assign a value of 10, which is integer, then print out its type. Again, change the value of x to string with text of hello, and finally change it to list, like this. When you run this, it works fine and you can see the updated type of same variable. This is different from languages like Java or C++ where you have to declare the type up front and stick with it. Python figures it out automatically. Flexible, but you need to be careful. Now for a modern Python feature, type hints. These are optional annotations that make your code cleaner and help catch bugs. Let's improve our variable declaration using type hints. When we define age, we simply define it like this, age equal 25. Now, since 25 or age is generally an integer, we can type hint it by using colon after age and write int. This makes your code self-documenting. Anyone reading your code instantly knows what type each variable should be. Python doesn't enforce these, they're just hints, but modern IDEs use them to catch mistakes before you run your code. And that's it. You now know about lists, tuples, sets, dictionaries, mutability, dynamic typing, type hints, and professional best practices. You're no longer a beginner, you're on your way to intermediate. In the next video, we're tackling Python operators, how to do calculations, comparisons, and logic operations with all these variables you've learned about. You won't want to miss it. If you made it this far, you're serious about learning Python. Drop a comment saying I finished advanced and let me know what topic you want next. Smash that like button, subscribe if you haven't already, and I'll see you in the next video. Keep coding.